Hi, my name is Mark Krasinovich. I'm CTO of Microsoft Azure, and I'm here to give you a lap around Azure Infrastructure as a Service. Now, Azure Infrastructure as a Service is just part of the Azure platform. I'm showing you this slide to give you an anchor for where we're going to be spending our time here. And in this diagram, you can see a layered view of the Azure platform, where at the bottom we've got our hardware, our data center infrastructure. Above that, we've got compute, storage, and networking. And above that, we've got dozens of PaaS services with some of the verticals, including cross-cutting services like our Azure Active Directory Identity service and our Visual Studio tooling service for continuous integration and continuous deployment. I'm, of course, going to be spending this time on compute, storage, and network focused on virtual machines. I'll also touch on containers a little bit. And in the context of virtual machines, touching on Azure Storage and the block storage support that it's got in it, as well as the network services that allow us to connect virtual machines together, as well as connect virtual machines to on-premises infrastructure. Now, to guide us on this journey through virtual machines, I'm going to leverage the Create Virtual Machine experience in the Azure Preview portal, where we'll be introduced to a number of the core concepts related to the virtual machine technologies in Azure. And I'll stop and dive into a discussion of each of those as we come across them. So let's go switch to the Preview portal, which I've got open here. You can see I've got a dashboard. If you're not familiar with the Preview portal, we've got a new button here, which is the key to creating any new type of resource in Azure. When we click on New, you can see that we've categorized the various resources. And I'm going to be focusing again on Infrastructure as a Service, which means compute. I get taken to a tab that shows us some of the operating system images we might want to deploy. This is a view of some of the recommended images and some of the most commonly used ones. But if I want to see the full set of images available to us, I simply click on Marketplace, and now there's a filtered view of the compute-related images and items that are in our marketplace. When we're creating a single virtual machine, which is what we're going to start with here, the first choice we've got to make is what operating system we want to deploy into that virtual machine. And there are a variety of different virtual machine operating system images available in the Azure portal, in the marketplace. So we, of course, have a collection of standard Windows operating system images. We also have a collection of Linux distributions. You can see here that we've got a number of different Linux distros offered, including Ubuntu, Oracle Linux, SUSE Linux, CentOS Linux. We also have images that include layered software, including databases like SQL Server and Oracle Database. And then we've got a variety of images that include other software baked into them already, like BizTalk Server, for example. If you're an MSDN subscriber, which many of you are, then you've got access to our MSDN-specific images, which include ones with Visual Studio built into them, with Dynamics GP built into them. And these images are great for dev and test environments and scenarios, and they come at a quite steep discount. So you can save 33 to 90% off of the full list price of what somebody not an MSDN subscriber would have to pay per hour for these virtual machines, or rather per minute. In addition to these more curated images that are part of the recommended set in the marketplace, we also have certified Azure images, which include other Linux distros and other applications available to you. Those are available in the Preview portal at this time, by the way. So let's switch back to the portal, and I'm going to pick Ubuntu Server, but I'm going to find it using the search facility. If I search for Linux, this is an easy way to go searching for images that match certain characteristics. And here I find a Linux Ubuntu Server image. The first thing I get asked here is to select a deployment model. I'm going to come back a little bit later in the presentation and explain the difference between Classic and Resource Manager. But here I'm going to select Resource Manager and press the Create button. And now I get taken through a little bit of a wizard that asks me for the different properties that I want to set for my virtual machine, starting with the name. And I'm going to just pick a fairly generic name here, my Linux VM. I'll pick my own name as the username. Authentication, I can use an SSH key or a password. I'm going to simply pick a password. Pick a subscription that I want to deploy into. and then I pick a resource group. And this is basically a name for the collection of resources, which can include this virtual machine as well as other ones that I want to put this virtual machine into. And I'm going to call this my Linux resource group. I'll explain again what resource groups in more detail later. The final thing I pick on this pane is where I want to deploy that virtual machine. Azure is a geo-scale public cloud, which means it has locations all around the world, and we pick which region in which geography we want our virtual machine to be placed, and the data associated with that virtual machine will stay in that region. When I'm done making my selection here, I can move on to picking the size. You can see that the portal recommends some of the most common sizes users want. You see D1, A1, and DS standard. Let's talk about what the virtual machine size options are in Azure by talking about the range of types, which go from A to G, with D in the middle. You can think of A as being the highest value. They're aimed at workloads that aren't that demanding in terms of throughput, ones that are used for dev test. Our G virtual machines, on the other hand, on the far right of the spectrum, those are for the most intense and extreme type workloads. Our largest G series virtual machines have the fastest processors available in Azure, have the most RAM available on any public cloud, and have large amounts of local SSD storage as well on them. In the middle is the D series. The D series also have SSD storage. They have fast CPUs on them. And a key aspect of picking the virtual machine size is whether you want to attach a premium disk to them or not. The virtual machines that are labeled S offer premium storage. And let me go back to the portal and show you the full set of virtual machines that we have to pick from, because when you say View All, you get shown these other offerings like the DS series that I mentioned, as well as the G series and the GS series that we've just been talking about, all the way down here to the largest, the GS5, which you can see will rack you up quite a good bill if you pick that one. I'm going to pick a DS standard, one of the most common virtual machines. And the next pane, that's where I get asked which type of storage I want to attach to it. So let's talk a little bit about standard versus premium storage. Our standard storage offering is for the most common workloads. It delivers up to 20,000 IOPS per storage account and 20 gigabits per second per storage account. It is offered for blobs, files, tables, and queues. Now, the reason that I mentioned which object types this is offered in is because virtual machines are based on what are called page blobs, a certain type of the blob technology. Standard storage is available for other object types, and if you want a standard storage disk attached to a virtual machine, you would be using a standard storage page blob, which you can access through our standard storage APIs, as well as attaching it to a virtual machine so that the virtual machine can use it as a disk. Our premium storage disks are offered by the premium storage backend. A premium storage backend account can deliver up to 80,000 IOPS and 64 gigabits per second. And this is the most of any cloud storage provider. The billing is based on the amount of data that you've provisioned, not the actual amount of data you've written. And that's a contrast to standard storage. So you provision a certain amount of storage capacity, and that gives you a certain amount of IOPS, and then you pay regardless of whether you're using that full amount of storage, but you're guaranteed a level of performance for low latency and high throughput. Premium storage offers only the page blob object type. In the future, it will include other types, including Azure file storage, but at this point, it's purely designed and aimed at block storage for virtual machines. I mentioned that the S designator on the D series and G series means that you can attach a premium storage disk, and because I've picked a DS virtual machine, I can attach a premium storage disk. I'm offered that option here. The virtual machine also has some limits. The largest GS series, the GS5, can support the full 80,000 IOPS on a virtual machine. Each disk that you attach has a limit, though, of 5,000 IOPS per disk. When you attach a premium storage disk, you're getting extremely low latency and high throughput. The latency you'll get is about 5 milliseconds for read and write if you don't leverage the local cache. One of the differentiators of Azure virtual machines is that they have SSD cache, like I mentioned, taking advantage of the server SSDs, and that offers less than 1 millisecond read latency. And if you're using write-back caching, can offer that same kind of latency for your writes. It's important to recognize that there's different levels of limits as you provision your virtual machine. And I'm not going to go into detail here other than to show you that there's limits on the disk. So I mentioned that the P30 disk, which is the largest premium disk with the highest IOPS, offers up to 5,000 IOPS. So you can't drive more than that amount of IOPS off a disk, but you can attach multiple disks. You can attach up to 64 disks on the GS5. And then you'll run into potentially other limits. Limits on the cache, and then at the bottom there you see that there's a limit on the DS1 virtual machine of a total of 3,200 IOPS. And there's also a bandwidth limit. So it's important to recognize as you're sizing your virtual machines, taking into account the various limits, so you can decide how many disks you want to attach and whether you want to take advantage of the local cache or not. Let's go back to the portal, and we're just going to let it sit with the default here. I'm going to press OK, and now we've got a summary view of everything that I've picked, and at that point I can press OK, and I'll be creating a virtual machine. In a couple minutes here, I'll have that Linux virtual machine we've just specified. That just touches on some of the core fundamentals of virtual machines. Let's go a little bit deeper and talk about things like how we do networking and load balancing and create high availability solutions on top of virtual machines. To do that, I'm going to switch to an existing virtual machine deployment. When I go back to the portal and I select resource groups, you can see I've got a number of resource groups. The one that I'm going to focus on here is one called web servers. When I click on web servers, I'm shown a list of the resources that are part of that web server resource group. You can see that there's two virtual machines, web servers 001 and web servers 002 in this resource group. And to highlight the different properties, like I've just mentioned, on virtual machines, I'm going to select web server 001, and we're going to explore all its various settings and discuss what they mean. When I click on properties over here, that just shows me some summary information, what IP address the virtual machine was assigned. There's a concept of a private IP address, which is internal to the Azure network, not exposed to the public internet. You can see the deployment ID and the resource ID, and this might show up in log files, for example, where I've deployed that virtual machine, which subscriptions it's in, and information about the subscription ID. When I click on the Disks tab, here you'll see which disks I've attached to this virtual machine. And this shows you what it would look like if previously, and when we created that Linux virtual machine, we not only took the default of just having an operating system disk, but we attached some data disks to it as well. Using these buttons up here, I can choose to create a new data disk and attach it to that virtual machine, specifying a size, as well as what caching type. And that refers to the caching I mentioned that is available on our local servers. Here you can see that I also can attach an existing data disk, and that would allow me to navigate through my Azure storage accounts and pick an existing page blob and attach it to this virtual machine. I'm not going to do that at this point in time, but rather continue on and talk about the IP address tab. So what are IP addresses? I mentioned public IP addresses. You'll see this concept of instance IP addresses, and you also see private IP addresses. Let's talk a little bit about IP addresses. And I'll start by talking about public and instance level IP addresses. Public IP addresses are IPv4 IP addresses that are routable from the internet and by default accessible from the internet. An instance level, and it can be load balanced. A public IP address can also be used to route to a particular virtual machine behind the load balancer. An instance IP address, or an instance level IP address, on the other hand, is one that is bound to a specific virtual machine, a single virtual machine. So you can choose to have a configuration like the one shown in the diagram where I've got two virtual machines, each have their own instance level IP address, and I can address each of those virtual machines through that publicly accessible IP address, or I can choose to put them behind a load balancer and have an IP address attached to the load balancer such that if I go to the load balanced IP address, I'll be accessing one or the other of the virtual machines depending on how the load balancer routes my traffic. And for creating a highly available solution, that's what you'd want to do, because if one of the virtual machine is down, for example, it's crashed or it's being updated and it's not able to serve traffic, the load balancer will take it out of rotation and route all incoming traffic to the healthy virtual machine. Let's talk a little bit about reserved IP addresses. So when you create a virtual machine like I did a little bit earlier, Azure dynamically assigned me an IP address. But you can also choose to sit on an IP address. You can retain it so that you can then leverage it later. And this is extremely useful in cases where you want to set up ACLs or routing rules for your on-premises networking infrastructure and make sure that those continue to work even if you shut down the virtual machine and restart it later. If it was a dynamically assigned IP address, you would lose that IP address and you would get another dynamically generated one assigned to it. With the reserved IP address, you can shut down the virtual machine, then recreate it, assigning it the same IP address, and now it would be accessible through your on-premises network rules if you'd set them up. You can also move them around, and another way to create high availability is to take that reserved IP address, as shown in the picture, and move it from one load balancer to another load balancer, or from one instance IP address to another instance IP address. So these give you some flexibility and some stability around IP addresses. Let's talk a little bit more about load balancing. And to show you load balancing, I'm going to come back and show you that I've got a load balance set here on this on these two virtual machines, the web set 001 and 002. And you can see that I've got, when I click this open, a number of configuration options on that load balance set. One of them is that I can specify the endpoint. So I can say which port I want to have load balanced. And when I pick a public port, that is what's exposed to the load balancer, to the internet traffic. And then I can map that to an internal port if I want to, so that, for example, I can have port 80 publicly available, but have that mapped to port 79 if I wanted to do that for some reason on my virtual machines. In most cases, you're going to just want that to let that be passed through and let port 80 on the load balancer map to port 80 on your virtual machines. The other thing I can do is set up rules on the probes. I mentioned that the load balancer won't route traffic to a virtual machine that's not healthy. And the way that you can configure that is to set the probe protocol, the probe path, the port, interval, and number of retries. What this is doing is allowing you to have some logic in your application respond to those probes. If, for example, if I set up a web server and I had a URL on it called health probe, then I might have be able to implement some logic that's more sophisticated than simply the virtual machine is not accessible. For example, I could set up a rule that says, well, not only does the virtual machine have to be up, but of course the website's got to be up and it's got to be able to take traffic. I set the port, and because I've got the load balancing rule here to map to port 80, the probe port is port 80. And then, depending on how quickly I want to detect failures or bring servers back into rotation, I can set the probe interval down to a few seconds and the number of retries greater than 5. I can set the number of retries to some number like 2, 3, 4, whatever I want it to be. And the probe has to not respond that number of times before the load balancer will consider it unhealthy. Switching back, let's talk a little bit more about networking in the context of virtual networks. So what I've done is talked about the IP addresses that I've mapped to my virtual machine. But in some cases, I want to bring my own network, my own set of IP addresses, and map them to a collection of virtual machines in a multi-tier application, for example. This is very common when I've got a front end, a middle tier, and a back end, and I want to segregate them from each other. I might also want to bring my own DNS server, as is the case when I have an Active Directory domain controller sitting inside of a virtual machine in Azure, and I want it to have its own DNS server that is working with the registered computers in that domain. To enable those kinds of options, we have virtual networks. Virtual networks, which I've got one configured here for my web servers, allows me to set up subnet rules of carving out an address space. So essentially what I do is I specify an address space, and this is the range of IP addresses that I want Azure to assign to my virtual machines. So I've got a 10 private IP address space here configured for these web servers. That means when I create web server 1, it's going to get a VNet IP address, one that's private to this collection of virtual machines, not accessible from the internet, chosen from this IP address range. So it might be 10.0.0.1, for example. And the second virtual machine might be 10.0.0.2. I can use subnets to carve out address spaces. I've only got one tier in this application, so I only have one subnet. But if I had a front end, a back end, and a middle tier, I would create subnets for each of those. And that would allow those virtual machines to get IP addresses from those subnets. Now, the reason why I'd want to have subnets for each of these tiers is that I can set up routing rules based on the IP addresses that those virtual machines would have, either in the firewall rules in those virtual machines or using something called network security groups, which is what I'll talk about next. With network security groups, I can set up rules for what kind of accesses virtual machines have to each other. I'm going to switch back to the portal, and I'm going to switch to another resource group here where I've got some network security groups set up. And this is the network security group resource. When I click that open, you can see over here in the settings, inbound security rules, outbound security rules, and that's where we would set up 5-tuple rules, which would say what's allowed in and what's allowed out. What is this virtual machine allowed to connect to and what is it not allowed to connect to? In this case, we allow, as an inbound security rule, SSH into the virtual machine, that no other port is open to the outside world. And this would make it so that even if I had another port that's open or a port that could be attacked, that port's simply not accessible from the outside world. Only the SSH port is allowed. And likewise, I can set outbound rules to prevent the virtual machine from talking out. If it was compromised, it would prevent the attacker that's compromised the virtual machine, for example, from contacting its own servers and transferring data out to them. Now, one of the things that you'll typically want to do with your virtual machines is establish secure connections from your own servers that are on-prem to those virtual machines up in the cloud, making them effectively a private extension of your own network infrastructure. And there's a number of different options we allow for that. Of course, the simplest way is just through internet connectivity. So you could set up an SSL endpoint, for example, on your web server and then access it through the public IP address. That traffic would be encrypted using your SSL cert. But the IP address of that website would be accessible on the external internet, and maybe if somebody discovered it, they could DDoS that endpoint or try to compromise it. So making a more secure connection means putting those virtual machines inside of a virtual network, connecting that virtual network through what's called a gateway back to your on-premises infrastructure, and then making it so that that virtual network either by not assigning it a public IP address or with network security group rules, not allowing it to talk to the outside world or allowing the outside world to talk to it. That tunnel that you have connected from your on-prem infrastructure to Azure, you'd also want to have go over either a VPN tunnel or your own network service provider's network into the Azure backbone. So let's talk about the options you have there. The simplest to set up, one that doesn't require any network administrator involvement, is secure point-to-site connectivity. And you can set that up by installing a VPN client on your laptop, your development system, and then connecting that to the gateway that you attach to the virtual network that the virtual machine is attached to. This means that the virtual machine is accessible only from that development system. It's not accessible from any other machine on your network, since they won't know how to find that server up in Azure, only through that VPN tunnel that's created on that laptop or development system. The next option is secure site-to-site connectivity, and that's when you have a VPN appliance, either a software appliance or a number of hardware appliances we support as connectivity options to Azure using this method. And that's one where you would typically get a network administrator involved. They're going to set up routing rules so that the internal network views Azure as an extension of it, and traffic that originates on any machine in that internal network can find the Azure virtual machines up in the cloud, essentially extending your own network up into the cloud. And this is one of those key reasons why you need to be able to bring your own IP address ranges to your virtual networks, because when you're doing this kind of connectivity, you don't want the IP addresses of the virtual network that your virtual machines are assigned to overlap or conflict with the IP addresses of your enterprise network. And then the final option, that's the one if you're really doing serious stuff with the cloud and hybrid that you'd want to take advantage of. It's something called ExpressRoute. And with ExpressRoute, you work with an exchange provider or a network service provider to connect your enterprise network through their devices into the Azure backbone. And there's a number of connectivity options. They're all highly available. Number of bandwidth options. This is guaranteed bandwidth through the network service provider, exchange provider's network into the Azure backbone. So direct access, not over the public internet, with high availability. And that's typically what you would do. Let's go back to our web server security, web server resource group, and go back to web server 001 and continue walking through these. I've just talked about load balance sets, a little bit about networking. Let's talk about availability sets now. One of the things that you'll typically want to do, especially in this kind of configuration that I've got here, I've got two web servers, and I'm able to access them both through a load balancer. Now, I want these virtual machines to have independent failure modes and also to be able to update them independently as well. So for that, I put them in what's called an availability set. An availability set is a grouping of virtual machines that are related to one another and that have availability constraints. So in this case, web server 001 and web server 002, I would assign to an availability set. And when they're assigned to an availability set, what Azure will do in the infrastructure is spread them across single points of failure in the data center, at least 3. Now in this example here, diagram, I only have 2 virtual machines, so they're going to be spread across 2. In the Azure data center infrastructure, the single point of failure is a rack. And so we call those fault domains, or FDs. And you can see here, I've got this multi-tier application with IaaS front ends and SQL back ends. They're each of those front end virtual machines are in one availability set and a back end are in another availability set. Now those front ends are going to be spread across fault domains so that if one of those racks fails or one of the servers fails, it doesn't take out both of those virtual machines. The other one will still be accessible and operating. The same thing for the back end. The other thing that Azure will do is when it's performing an infrastructure update of the hypervisor and needs to reboot those virtual machines, it will guarantee that no more than one of those virtual machines will be down at a time. So as it's walking through the servers in the data center, the Azure infrastructure updating mechanism will update the server underneath that IaaS front end 1, make sure that that virtual machine's back up and running, and then a little bit later, update the server underneath IaaS machine 2. And that way, at least one of those virtual machines is available through that constant update process. And I've, just going back here to the resource group, have put these web servers in an availability set so that they get that high availability behavior. The next thing we'll take a look at are extensions, and this is a powerful feature of the Azure platform. It's the ability to dynamically inject code into virtual machines, either at the time you provision them, or even later after you've already got them up and running. In this web server 001, I have my favorite Azure extension. It's called BGInfo, and those of you not familiar with sysinternals might be wondering why I'm saying it's my favorite. I'm author of sysinternals tools, and BGInfo is one of my sysinternals tools. It's purpose is when you run it, it will display information on the desktop background on Windows. So when you RDP into the system, you will see information like the name of the machine, what IP address it has, and other details that will help you identify the configuration of that machine. And by default, it will be installed in the Azure virtual machines you create through that portal's provisioning process. But there are lots of other extensions you can install. When I say add, you get an idea for the variety. We've got security extensions from Microsoft, of course. You can install our Microsoft anti-malware agent. There's anti-malware agents and disk encryption agents from Symantec, Trend Micro, CloudLink, and McAfee. We've got deployment extensions that will make it so that you can deploy code and configuration into those virtual machines. And they include some of the most popular ones like Chef, Puppet, Octopus, and of course our own PowerShell scripting, as well as PowerShell DSC. And then we've got a whole set of others. We've got access recovery. We've got Docker extensions, so you can, after the Docker extensions in the virtual machine, you can deploy Docker containers to it. We've got monitoring agents, diagnostic agents, and you can also dynamically inject the Visual Studio debugger so that you can do Visual Studio debugging of code inside that virtual machine from your Visual Studio installation on your own developer laptop or desktop. Let's switch and talk a little bit about resource groups. So resource groups, which you've seen the name resource groups a number of times as I've walked through the portal experience. And I told you that I was going to defer a discussion of resource groups into a little bit later. Resource groups are a very powerful concept in Azure, and the entire portal experience is designed around them. That's why you can see up here in the upper right, by default, you see this menu item here, resource groups, which will list the resource groups that are part of your subscription. Resource groups, you've probably already gathered, they're a collection of resources, and resources of different resource types. When I looked at the web servers resource group, for example, you saw that I had virtual machine resources. I also had some other resources. Likewise, when I went and looked at that Linux Diag resource group, I had some other resource types in that as well. Let's talk a little bit about why we've come up with resource groups and resource types. First is that resource groups give you the ability to manage a collection of related resources, or related objects in a cloud application together. When I go delete a resource group, by default, all of the resources in that resource group will get deleted together at the time I delete the resource group. So it's a unit of lifecycle management. But it's also a container for those resource groups in other ways, where those resources are sharing attributes. And I'm going to talk a little bit about them. One of them is resource-based access control, which provides the ability for granting access to users to be able to interact with those resources as a group, as a collection, as well as tagging so that I can look at my bill or do queries of the resources in my subscription and find all of them that meet some tag that I might be interested in. Like I might be looking for all the ones that I've created and I've tagged them all as Mark, whereas some other developer that's sharing my subscription, they might tag theirs as Joe. And now we can easily see with queries in the portal and in PowerShell or the Azure CLI, which resources are mine versus which are Joe's. Now, the reason that I got asked at that beginning of the presentation when I was creating that virtual machine whether I wanted to deploy it as classic or as a resource group is that we've introduced a different model for the objects that make up virtual machines that are more integrated with the Azure Resource Manager, which is the service that implements resource groups. Previous to Azure Resource Manager, we had something called the Azure Service Manager, and that's what we call the V1 of the IaaS APIs. The Azure Service model was a model that tightly coupled many of these resources together. So we had the concept of a cloud service, which was a collection of virtual machines. We had storage accounts and virtual networks, and all of these were discrete objects that you had to go create independently from one another, and that were only loosely connected. The only things that were tightly connected and too tightly connected were the networking objects and the virtual machines as part of the cloud service. So moving to the Azure Resource Manager model, we redesigned the IaaS APIs, broke out the objects that should be separate into their own resource types. And you can see that we've got virtual machines, of course. We also have network adapters as their own type. We have IP addresses their own type, and more. And by being their own type, that allows us to take them and set role-based access control on them independently, to tag them, to move them around. So if I create a network adapter, I can attach it to different virtual machines. And if I create complex rules associated with network security group rules, you can see associated with that NIC, those security group rules move with the NIC as I move it from virtual machine to virtual machine. Now let's talk a little bit about RBAC. I'm going to switch back to the portal. And let's go to Linux Diag, for example, here. And up here in the portal, I see a couple of figures here, and that is labeled access. And that is what allows me to set role-based access control rules for who can do different things to these resources of the resource group, the subscription at a higher level, or I can dig down into individual resources and set rules on them. Now, what I'm looking at is the Linux Diag resource group, and there's a few resources in that group. You can see I've got a virtual machine Linux Diag 1. I've got that network security group we looked at earlier. We've got a network adapter and a number of virtual network and a number of other resources. I've got one what's called role assignment on this resource group, but I can create other ones by saying add. And I get asked a few questions here. I get asked to select a role, and then I get asked to select users. So let's spend a second here talking about what is RBAC in the first place, what are roles, and what are role assignments that we use users for. Role-based access control really is saying who can do what to a particular scope. A scope being a subscription, a resource group, or an individual resource. And the types of actions that we're talking about include things like modifying, reading, updating, and actions that are specific to the resource type. Reading is something that's pretty universal. So the reader's role would mean, the reader's role definition would say, anybody that's a member of this role can read from the objects that that role is assigned to. Role definitions are the assignment of those permissions. So if, like I said, the reader role by definition has read access. The owner role has full access. The contributor role cannot modify RBAC rules, but can make modifications to resources. And so this gives them constrained control over resources without being able to give themselves more access to other resources they shouldn't have access to, or give other users access that they shouldn't have. When I go back and look at the selector role, you can see that there's a number of other roles that are built in to Azure that we can assign, that all have their various types of permissions associated with them, giving them various control over the various objects in my resource group. If I pick contributor, for example, then the next step is user. And this is where I would take and I can add users from my Active Directory tenant, or the administrators that are assigned to my subscription, and add them to to that role. And the default scope here is the resource group, because that's what I started setting this on. But the scope matters, and the scope is inherited. So if we take a look at the way that scopes and role assignments propagate, as I mentioned, subscriptions encompass resource groups, and resource groups encompass resources. So if I assign users to a role that I assign to this subscription scope, then they have accesses to anything in that subscription, all the resource groups and all the resources. But I can choose to assign users to roles that are assigned to specific resources, and now I've very tightly controlled access to those resources. So that's one of the benefits that we get with resource groups, is this role-based access control that applies uniformly across every object in the Azure platform, whether it's a virtual machine, a storage account, a virtual network, a machine learning object, Azure database, a website. Everything in the Azure control plane is accessible and controllable through resource groups and therefore role-based access control. Now, the other property I mentioned that you get with role-based access control, the other capability, is you can tag resources or resource groups. And the reason why you might want to tag, like I mentioned, is so that you can keep track of various properties. And let's go back to my Linux diag resource group. And there's a little tag icon. And this is completely freeform. So I can say my tag, and I can give it a value of this value. And at that point, when I say save, I've just tagged that. And like I mentioned, when I perform queries in the portal to look up resources by tag, then I'll be able to find everything. I could say search for only resources or resource groups that have a my tag value of this value, and this resource group would pop to the top. But where this really, I think, becomes extremely useful is in tracking costs, which is obviously extremely important as you're developing and deploying cloud services. You want to keep track of the cost of those services. So when you get that bill every month, or when you go do a billing report in the portal, what you can do is download a Excel file that has the breakdown of costs by all the resources. And if you want to see how much all of the resources that have a value of this value for my tag, you simply perform an Excel filter and summarize the costs. And now I could see the full costs of everything. A place where everything that matches that tag filter. So for example, I might have a subscription that has marketing resources as well as developer resources. And by tagging them appropriately, I can take a look at the bill and see how much the marketing resources are costing me versus the developer resources, spanning all the resource groups and resources in that subscription. Where Resource Manager, though, really shines, it's got these great capabilities like role-based access control, the lifecycle management of resources, the grouping that we get in the portal and in the command line tooling and APIs. But where it really shines is it's in its support for templates, Resource Manager templates. Let's take a look at what the template experience looks like. By going to New, and I'm going to go to Compute. When we did this the first time, I created a single virtual machine. But what templates allow us to do are create very complex cloud applications that consist of lots of resources, lots of virtual machines. And one of the most complex applications there is, infrastructure as a service applications, is a highly available SharePoint farm, which I've got right here. And when I create this, you can see I'm asked a number of different parameters or values for parameters, like which resource group I want to put it in, the username and password for the SharePoint farm. You can see that I've got domain controller settings that I can configure. What's the hostname prefix? What's the forest root domain? I've got SQL servers to configure. I've got SharePoint servers. I've got virtual networks. So lots of different complex settings. Without templates, a SharePoint farm script to set up is hundreds and hundreds of complex lines. Or if you did it manually, it would take you hours and hours. You'd have to hire a consultant to set up a SharePoint farm. But with the power of templates, a declarative model that says exactly what the Azure resources should look like, the virtual machines, the virtual network, the configuration settings for the code inside the virtual machines, I've got a very reproducible model that I can then take and deploy in test environments, in production environments, with its own customized configuration, and have a very high confidence that deploying that's going to just work, and it's going to work as quickly as it can, because Azure Resource Manager handles all the complexities of knowing when the SharePoint domain controller is finished deploying, so that it can then create the SQL servers and domain join the SQL servers. All of these dependencies between the resources that determine what order they need to be provisioned and maybe what order configuration needs to flow out of one into another. For example, the SQL Server's connection string needs to be plumbed in to the SharePoint Farms front end. All of that is just automatically plumbed through Azure Resource Manager as declared in the template. I've already deployed this SharePoint Farm template, and if we go take a look at it, you can get an idea of just how complicated this thing is and just how easy it was to create just with a few clicks up there. You can see here's the SharePoint app servers, the domain controllers, and the SQL servers, and the web servers. Here's the virtual network. And you can see that here we've got the public IP addresses for these different tiers. It's really important if you're doing anything more than one-off virtual machine creation to become familiar with the power of templates and what templates are available to you. You don't need to necessarily author them, but using the marketplace, you can go find templates for common infrastructure as a service solutions like SharePoint, but you can also find a whole lot more here in GitHub. Under the Azure repository, we've got another sub-repo called Azure Quick Start Templates, which include hundreds of different templates. These templates might be useful on their own, but they're also potentially useful as starting points for creating your own templates for your own applications that don't fit any of the common ones that you'll find here. You can easily search for a particular template. Like you can see here, earlier I searched for SharePoint to find the template for that highly available SharePoint farm that we're looking at. And that takes me to this page right here, which shows me all the artifacts necessary to deploy that SharePoint farm that we were just looking at as an Azure Resource Manager template. When I click on Azure Deploy.json, we're going to see some of those parameters because templates are parameterized, and that's how the portal knows to ask those questions about what settings I want for example, my virtual network address range, and there's a default value. That showed up in the portal if I'd clicked on that virtual network section. The portal knows to ask those questions by looking at these parameter sections. And those parameters then get plumbed down into deeper parts in the template that specify. You can see there's a whole lot of parameters here in this SharePoint farm template. But we start to see down here resources. So we see here's a load balancer resource. And this load balancer resource depends on IP address being available because that IP address needs to be assigned to the load balancer. I'm not going to go into much more depth here on resource templates, but safe to say that you can create very complex orchestrations in a declarative way, which makes it easy to reason over, easy to update, easy to maintain, that live through the whole life cycle of the application. If I deployed this SharePoint template to Azure Resource Manager and then came back and modified the template and gave Azure Resource Manager the updated template, Azure Resource Manager would simply apply the changes, not completely redeploy those resources, but only apply the changes that I'd made. The other thing you can do right here from GitHub, by the way, is deploy right to Azure. So here's another way that I could go and deploy that SharePoint farm template. Of course, we saw it there in the marketplace, but I can click a template from any place in that GitHub repository, and there I get the portal provisioning experience directly from there. So everything I've been doing thus far has been in the Azure portal, but that's by no means the only way to interact with Azure. In fact, as you get more sophisticated, you'll probably be interacting more with Azure using automation and leveraging the Azure command line, CLI, on Mac or Linux, or PowerShell on Windows. To give you a flavor of what those interactions would look like, let me switch to a command prompt here on my Mac and show you the Azure command with the group option. The group option refers to resource group, and you can see that when I type that, Azure CLI is going to show me all the different types of options that I've got for interacting with resource groups in my subscription. One of them is Azure Group List, which will show me all the resource groups in my subscription. And there you can see AzureCon 2015, one of the resource groups that I interacted with a little bit earlier. I can see the resources within that by saying Azure Group show AzureCon 2015, and that will dump out the list of resources inside that resource group. We've got an equivalent experience over in PowerShell. So if I say Azure Resource Group, this will just simply dump me all the resource groups in a very similar format. And then, of course, I can set a filter for AzureCon 2015, and now that will show me the resources within that resource group. Of course, there's Azure commandlets and CLI commands for interacting with all the different resource types that we've shown you, virtual networks, NICs, load balancers, but this just gives you a flavor of what's available. I've given you a whirlwind tour of virtual machine capabilities and properties and some of the considerations for setting them up. What I'm going to do here at the end is just spend a few minutes talking about things that are coming, some of the things we've announced here at AzureCon. One of them is virtual machine scale sets, and the other one is our container service. Now, to set up virtual machine container service and scale sets, let me talk a little bit about Azure's work with Docker. Many of you are looking at the next generation of development, and that means using containers. Even if you're an IT pro, you're probably thinking about containers because many applications now are containerized, and if you're going to be deploying a containerized application, then you're going to be using Docker to deploy those containers and probably saying, what kind of support does Azure give me for that? If you're a developer, of course, working on applications, you're probably looking at containers as a great way to speed up your dev test cycles and to get reproducible performance and behaviors when you move from dev to production. And so we're also interested in what Azure's got to offer when it comes to containers. This slide shows you a summary of the great work we've been doing with Docker over the last year and a half to bring Docker container support not just into Azure, but into Windows Server, into our marketplace in the form of a Docker Trusted Repository, which, by the way, is built on top of an Azure Resource Manager template, as well as to bring support of containers into Windows Server. When you talk about a containerized application, you're often talking about breaking that application up into what are called microservices, discrete components that can be revised independently, scaled independently. And when you have an application that's broken up that way, you typically are going to take that application and deploy it to a collection of virtual machines. This virtual machine infrastructure we call a cluster. And when it comes to a cluster that you lay down a containerized application onto, in most cases, you want to take advantage of the ability to scale up and down the cluster dynamically. And most modern applications are scalable for these reasons so that they can consume resources only as necessary to handle the load that they're under. So for that, we've defined a new virtual machine type that's coming soon in public preview called virtual machine scale sets. So I'm just going to spend a minute here introducing them to you to give you an idea of what's coming and how this is going to make things like cluster management simpler. Without virtual machine scale sets, if you wanted to create a cluster, you'd have to create individual discrete virtual machines and then make them all available to the cluster manager to deploy those containers onto. But with virtual machine scale sets, you simply define a virtual machine type and then a scale count. And then you can scale up and down the virtual machine scale set. And when you scale it up, it simply creates another clone of that template virtual machine image. So here I've got a virtual machine scale set with 4 virtual machines in it. You've got the concept of a scalable NIC. So I define the NIC properties, the network adapter properties. And whenever I scale out a virtual machine, it gets its own copy of that NIC. So if, for example, I assign that NIC to a subnet, that virtual machine will get an IP address from that subnet. Same thing for storage. I'll specify a scalable storage account, and now when I scale out the virtual machine, it will have an operating system disk and data disks, if I specified, that are created out of that scalable storage account. So this makes it much easier to keep track of resources, much easier to scale in and out. And to show you just show you the scalability of scale sets, I'm going to go back here to the browser, and show you something called Azure Resource Explorer. So Azure Resource Explorer, just do a search and you can come across this tool we've got called Azure Resource Explorer. When you log in to your Azure subscription, it will show you the various resource groups you've got in your subscription. And you can see that I've got here a resource group called AzureCon 2015, it's the one that we've been looking at. And I've got in the Microsoft Compute namespace an availability set, but I also have an example of a virtual machine scale set. And here's the JSON values for that scale set. You can see that in a scale set has a property called capacity. And if I deploy this, or when it was deployed, that property value was 5. If I took this and I modified it and set it to 7 and then gave it back to Azure Resource Manager, Azure Resource Manager would scale out the virtual machine scale set to having 7 virtual machines instead of 5. Likewise, if I'd set it to 3, it would take away 2 of the virtual machines. So it makes it very easy. And this Azure Resource Explorer lets you get a deeper view of deployed resources by looking at the various JSON that would make up their templates. So the next thing that I mentioned that I'd give you a preview of, and which I demoed this morning in the keynote, is the Azure Container Service. And the Azure Container Service is our goal here is to make it very easy for you to deploy containers onto a cluster. Initially, we'll have clusters that are based on discrete virtual machines. But ideally, clusters will be built on virtual machine scale sets. And when they're available, our Azure Container Service is taking advantage of virtual machine scale sets rather than discrete virtual machines. On top of that, you can either put Linux machines or Windows Server machines. You can bring your own operating system image out of any of the images that I showed you, or you can create your own images with your own code baked into them, and then bring your own container technology. Now, we're going to have some container technology built into the Azure Container Service, and that's what we have there called service tooling. That is the Azure Container Service resource provider. When you go to the Azure portal, when this service is available, and you say you want a cluster, you'll specify the base operating system image, the disk configuration, what extensions you want installed in it, and what the container service will do is go create a virtual machine scale set with the number of instances, and then place Mesos into it, the Mesos container orchestration service into that. At that point, it will also ask you if you want to configure a swarm endpoint on it. And it will also install the Marathon and Kronos Mesos application framework, so you can immediately start deploying containers or Marathon applications or Kronos applications to your Mesos cluster very easily. Likewise, the swarm endpoint will let you deploy Docker images as well as compose files that consist of multiple Docker images to that cluster as well. So this really simplifies and abstracts the cluster management away from you, and you'll simply specify the scale of the cluster, and the Azure Container Service resource provider will do the work of monitoring the health of the cluster as well as letting you know what the endpoints are for the various cluster orchestration endpoints. So that's a quick whirlwind tour of our virtual machine capabilities. I hope you found this interesting, and even if you're somebody that's somewhat familiar with Azure and infrastructure as a service, maybe you learned something new to take away from this. But I encourage you to go and start using Azure today to get your applications, whether you're lifting and shifting an existing application or building a cloud-native application where you're going to be taking advantage of Docker containers. Azure is the enterprise-grade partner for your applications. Thank you very much.